Today we're going to discuss and demonstrate using Pololu Maestro animation controllers in place of 1031 Systems Animator board for replicating props that we set up last Halloween. Let's see what it looks like.
Okay, here we are on Halloween, walking up the front porch. Da 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 da, everything looks nice. La la la.
This is a rough schematic of the hookups for the Pololu Maestro controllers that we're using for our props. So we're going to have a Maestro Mini 18. It's going to be board ID number 12. And we're going to use it to control all of the digital outputs and the 5-volt servo for the jaw of the skull. And all the inputs will go to this one as well. Then we're going to use a separate Maestro Micro, which will be board ID 13, and we use that just for controlling the 12-volt servo for operating the door. So we're going to connect our basic run/reset input to pin 0, the main trigger input to 1, and then our motion sensor trigger input will go to pin 2. We're going to use 6 through 10 as our outputs for digital controls of the two lightning flashes, the upper lights around the ceiling, and the left and right eye LEDs of the jaw. And then we use pin 17 as a PWM output to control our 5-volt servo. And on the micro, we'll use pin 2 as a 12-volt output for operating the door servo. We then connect our XTX here to pass controls that come from the USB port from the PC through the Mini 18 and over to the Maestro Micro. And then that way we're controlling both of these boards and controlling all of the things attached to them. Next thing we need to do is to set up the two Maestro controllers to match the control types that we want to use. So we will keep our schematic handy. Pin 0, 1, 2 are inputs, 6, 7, 8, 9, 10 are digital outputs, 17 is a servo output. So we're looking at the control window for Maestro's control center. We've attached it to our Mini. So you can see there's 18 channels here, 0 through 17. So we need to set up what the channels look like. So the first thing we'll do is we'll go to channel 0, make it an input, 1's an input, 2's an input. We can go ahead and skip 3, 4, 5. So 6, 7, 8, 9, 10 are digital outputs. And pin 17 is a servo. Now we do want to set the range of values on that, but we're going to leave that open for now. We'll come back and do that later. All right. Next thing we'll do is we'll go to our serial settings, and what we want is to set this to USB chained. So that basically says we're going to send USB commands to it, and then we're going to chain its output through the RX and TX pins off to our Mini. Device number here is 13. I said in the schematic we want that to be number 12, so I'll make that number 12 right there, and that should be all we need to do. We'll check our status. So now we will write that out to our board by pressing Apply Settings. Now we can see those are inputs, these are outputs, and these are servos. And we are done setting up the Mini. Now we'll set up the micro. So just disconnect your USB from the Mini. plug it into your micro, and the display should change to showing our 6 channels. Now, here we have this as an input. We're going to change this. We only want to have a servo connected here, so we'll just make all these servos for now. And we want the board to be identified as board 13. And we'll go ahead and make it UART detect baud rate. And so we'll let the two boards figure out what their baud rate is. All right. Channel settings are okay. We'll go back to status and we will apply settings. And these are all now servos. 2 is going to be our control. And that's it for programming the 2 Pololu Maestros. The next thing we need to do is to build our table defs file. The table defs file, you might recall, associates ports that we reference in Hauntimator to the actual hardware channels that come out of our Maestros. So, first thing we'll do, we'll bring up Hauntimator. We want to use the exact same animation for this screaming skull with all the exact same data files. So we're going to go pull up that same animation, and then we're going to pull up the port map. So the port map shows you what channels are assigned to what numeric ports. So we have 5 digital ports assigned and our 2 PWM ports. All right, I'll stick that over here in the corner. And next I'll bring our schematic over. So this is the schematic we're working with. I actually made a small change to this from the one that you saw previously in the video. I swapped the lights and lightning 2 channels so that the order of lightning 1, lights, and 2 matches lightning top and lightning over here. That way I'm not changing the port maps, I'm not changing anything in the animation, I'm actually just going to rewire it a little differently. Clearly, if you're doing it in the opposite direction, where you've built your system already and now you're building Hauntimator to match it, you do it in the opposite direction. You assign your ports to match your schematic. All right, so now we have our schematic and our set of ports. So now we're going to build the table defs file. Actually, I've already built it for you. This is how we do it. First thing we'll do is we're going to assign our 2 PWM ports. We're going to put the first one, this is the jaw. It's a 5-volt servo, so we're going to run it off of the Mini, which is board 12. So we're going to set PWM. It's going to be board 12. First port is 16. That's because the jaw down here is assigned to port number 16. Count of 1, because we're only assigning 1 port with this one call. And the first channel is 17 because it's attached to channel 17 on the Mini. Similarly, we're going to, on board 13, that's our 12-volt door servo. That's going to be first port 17, doors on port 17, just one of them, and it's going to be on channel 2 because we're attaching it to channel 2 on the micro. All right, so next we will set up our digital ports. Now, because I swapped these, I can do all 3 of these with one call. So we configure Maestro Digital. We're going to do it on port 12. We're going to start with port 0 because these start with 0 over here, 0, 1, and 2. First channel is 6 because they're connecting to 6, 7, and 8 right here. And there's 3 of them. So that configures all 3 of these for us with one call. Now, because these are not contiguous over here, we need to assign those with separate calls. So the right eye will be connected to first port 9. And we are going to set that to channel 10. The right eye is on channel 10, of course. And there's one of them. And then our other eye, the left eye, will be on port 11. and that's going to be channel 9. So channel 9 is our left eye, channel 10 is the right eye. Okay. Now we're going to assign these three inputs over here, trigger, main, and run. We do a separate call for each of those. So we're going to configure the run input to be on board 12, channel 0, the main input to be on board 12, channel 1, and the trigger input to be on board 12, channel 2. It's exactly the way they're assigned over here. And here we have the final wired up system to do our testing with. We've got the Maestro Mini on the left, the Micro on the right, above the proto board. We have 12 volts going up to the Micro, 5 volts going to the Mini. We've got the 12 volt servo in front, 5 volt servos in the jaw of the skull, of course. To avoid having to wire up 120 volts with relays and such not, I just used LEDs. There's two LEDs on the proto board, two blue ones for the two lightning channels, and a white one for the upper light channels. There's also a couple buttons there for the run and main inputs, as well as a IR sensor, motion sensor to hook up to trigger. Once we have the animation all set up and all of our hardware assembled, we're ready to actually play back the animations. To do that, we'll run the control emulator Python program under Python, and we'll give it a pointer to where the CSV file and the wave file are for our particular animation or set of animations. Running this pops up a little widget, tells you what's playing, which is nothing at the moment because it's stopped. Now the reset, main, and trigger buttons correspond to the three controls that we set up on the hardware. So there's a reset button and a main button, and the trigger is tied to a motion sensor. But we can actually trigger those directly from the keyboard for testing as well. So we'll go ahead and hit T. And that triggers our animation. And it completes. So main is a trigger that plays and stops. T is a trigger that'll trigger it once, but won't re-trigger it if you hit it again. And then reset resets everything back to the beginning. Rescans the input directory to see if there's additional animations available, whatever. Hitting Q, of course, does a quit. This can be run without a head if you wish. You can run it in background and have it output text to the log file. This allows you to run things automatically at startup if you want to use, for example, a Raspberry Pi to do this control, things like that, and then have everything actually controlled by the hardware itself rather than from the keyboard. Now we'll test the motion sensor, which is mounted in the back of the board, so hopefully I will reach to the back and it will start right up. Now we'll trigger it using the main trigger button.